Let's talk about solving rational equations. There are two main types of rational equations you will see. There's the type that has one rational expression equal to one rational expression, like this example I wrote right here. For those, you just need to cross multiply and solve. For type 2, you have more than two rational expressions that are in the equation. So for example, if you have this one that has multiple rational expressions, you want to look for the least common denominator, multiply every term by that least common denominator, and then solve. And remember, always check your solution, because our denominator cannot equal 0. So if your solution would make one of your original denominators equal 0, it's not part of your solution. Let's look at some examples. All right, so for example 1, I have 3 over x equals 12 over x plus 7. So this is type 1, because I just have one rational expression equal to one more rational expression. So I can cross multiply and then solve from there. So I'm going to say 3 times x plus 7 equals x times 12, or 12 times x. So 3 times x plus 7 equals 12x. Then I just need to solve from there. So you can tell that it already got rid of the fractions when we cross multiplied. So I'm going to distribute the 3. So I end up with 3x plus 21 equals 12x. So like we solve any equation, you want to move the term that's the smallest with your variable to keep things positive. So 21 equals 12x minus 3x, which is 9x. Then we want to divide by 9, and then we can just reduce. So we get x equals, and then 21 over 9, they both divide by 3 evenly. So we end up with x equals 7/3. Now before we put that as our answer, you just want to double check. Would that make either one of these denominators equal to 0? That's the only thing you have to check for, but you can plug it in if you have time and make sure that this makes a true statement, and then you definitely know you have the right answer. But I'm just originally checking to see that x, if it were 7/3, is not 0, so that's good. And if this x were 7/3 plus 7, that denominator would not be 0 either. So we're going to leave that answer. All right, so number 2, we have 2 over 3x minus 5 equals 4 over x minus 15. So it's another one that's just the type 1 that we can cross multiply and solve from there. So we have 2 times x minus 15 is equal to 4 times 3x minus 5. So we want to distribute the 2 and distribute the 4 and bring down 2x minus 30 equals 12x minus 20. So then I want to subtract the smallest term with the variable to keep things as positive as possible. So bring down the negative 30 that's left over. 12x minus 2x is 10x. Bring down the minus 20. Then I can add 20. So I get negative 10 equals 10x, and I need to divide both sides by 10. So I end up with x equals negative 1. Now we need to check and make sure, does x equal to negative 1 make either one of our original denominators equal to 0? So 3 times negative 1 is negative 3, minus 5 is negative 8. Negative 8 is fine, it just can't equal 0. If x were negative 1 for this denominator, it'd be negative 1 minus 15, and that's negative 16, which is still fine, just can't have a 0. So we have x equals negative 1 for our solution. Let's look at example 3. We have 3 over 2x minus 5 over 3x is equal to 2. So we do have these two rational expressions, but if I were to add the 5 over 3x to this side, I still would have two terms over here. So I don't have the ability to just cross multiply and solve. I need to use the type 2 method, which is to find the least common denominator and multiply everything by that, and then bring down what I have and solve. So 2x and 3x and a 1 are my denominators. So 6x would be the least common denominator. So I'm going to multiply every term in the entire equation by 6x. So 6x divided by 2x would leave me with 3. 6x divided by 3x would leave me with 2. And 6x divided by 1 still leaves me with the 6x. So then I just need to multiply what's left. So 3 times 3 is 9. Minus 2 times 5 is 10 equals 2 times 6x, which would be 12x. So 9 minus 10 is negative 1. equals 12x, and then I just need to divide by 12. So I end up with x equals negative 1 over 12. And we are just checking to make sure that that does not make the denominator equal to 0. So if x were negative 1 over 12, that would still be okay. If x were negative 1 over 12 here, that would still be okay. So we're going to leave it. All right, I have smudged out my 2. Let me write that back. So we have a 2 and a 2y here. All right, so on example 4, this is the type that has more than 2 rational expressions. So I definitely cannot cross multiply. I need to find the least common denominator and multiply every term by that number. So I have y, I have 2, and I have 2y. So the least common denominator between those 3 denominators would be 2y. So I'm going to multiply every term by 2y, and it'll cancel out the denominators. That's the magical part. So 2y divided by y, the y's will cancel out. And then 2y divided by 2, the 2's will cancel out. And 2y divided by 2y will totally cancel out. So I'm left with 2 times 2 is 4. 1 times y would just be y. And then 5 is left over here by itself. So then I have a nice simple equation to solve. It certainly didn't start out looking like it would be that easy. So we end up with y is equal to 1. And we just have to make sure that that would not make a denominator equal to 0. And for this one, it's okay. 1 would be okay. 2 times 1 would be okay. Let's look at 2 more examples. So these obviously look a little bit larger. Let's see what we can do to work these out. We have 5 over x squared minus 7x plus 12 minus 2 over x minus 3 equals 5 over x minus 4. What we need to do when we see a denominator like this trinomial here is we need to factor it first and see what our least common denominator would be, because this is definitely a type 2 rational equation. So I'm going to go ahead and factor what would multiply to give me 12 and add up to negative 7. That would be x minus 3 and x minus 4. So now I have rewritten that denominator. I can kind of mark it out because now I've represented that with x minus 3, x minus 4. I don't need both anymore. And now I can tell my least common denominator has to include all of my denominators, but no more than that. So x minus 3, x minus 4 would include all of these 3 denominators, what they have. I wouldn't need any extra. So I'm going to multiply every term by x minus 3, x minus 4. Which might look like it takes a lot of writing, but really it pays off because you can really see what happens to your denominators after you write that down. So in the first rational expression, this whole denominator would cancel out. So I'd bring down the 5. In the second rational expression, just the x minus 3 would cancel out. I bring down minus 2 times x minus 4. And in the third one, x minus 4 would cancel out. So I bring down 5 times x minus 3, which looks a whole lot better. And now I can start solving. I'm going to start with distributing. So let's say 5. If I distribute negative 2, I get negative 2x plus 8. And if I distribute the 5 over here, I get 5x minus 15. So let's combine like terms on this side. So 5 plus 8 would be 13. Bring down 5x minus 15 for now. You always want to move the variable that is the smallest coefficient. It helps keep your terms positive. So if I add 2x, I get 13 equals 7x minus 15. I'm going to add 15. So I get 28 equals 7x. And if I divide both sides by 7, I get x equals 4. Now we just have to check. Would that make any of my denominators equal to 0? So right here, if x were equal to 4, that would be 4 minus 4, and that would equal 0. So I actually cannot include this as my solution. So even after all of this work, my final answer would be no solution. All right, let's look at one more example. Number 6. I'm going to use a different color to help it separate from all that blue over there. We have 4n squared over n squared minus 9 minus 2n over n plus 3 equals 3 over n minus 3. So first let's factor anything that we can so we can find the least common denominator. So n squared minus 9 is a difference of squares. So I factored it as n minus 3, n plus 3. Now I see that my least common denominator would be this one. N minus 3, n plus 3 includes all three denominators without having any extra. So I'm going to multiply everything by n minus 3, n plus 3. And I can go ahead and cancel out the n squared minus 9 because I can tell that it's rewritten now as n minus 3, n plus 3, so I don't need both. This denominator would completely cancel out. So I can bring down the numerator 4n squared. The n plus 3 will go away, so I have minus 2n times n minus 3. And n minus 3 goes away, so I have 3 times n plus 3. So now we can start to solve what we have left. So I have 4n squared. I'm going to distribute, so I get negative 2n squared or minus 2n squared plus 6n equals 3n plus 9. So when you see something squared, you're going to probably end up with something quadratic if that doesn't cancel out, which this one does not. 4n squared minus 2n squared is 2n squared. So since I have a squared term, I know this is a quadratic equation from here on out. So I need to move all the terms to one side. So I'm going to go ahead and subtract 3n to save a little bit of work. So I'm going to add the 3n because 6n minus 3n is 3n. I'm going to go ahead and subtract the 9. So I went ahead and combined 4n squared minus 2n squared is 2n squared. I noticed it's quadratic, so I went ahead and moved these to the other side, and now I have my quadratic equation in standard form. The first thing we like to look for is, does this factor? Because factoring is usually the quickest and easiest method to solve from here. So we need numbers that will multiply to be negative 18 and add up to be 3. So 6 and negative 3 are numbers that would work. So we can factor. There's no need to use quadratic formula if you can factor. It'll save you a lot of time and energy. So let's put 2n in both, but we're going to take out the 2 before we're finished. We're going to put plus 6 and minus 3, and it's still all equal to 0. I'm going to take out the 2, so I have n plus 3, 2n minus 3. Now we have to finish solving. So if n plus 3 equals 0, n would equal negative 3. And if 2n minus 3 equals 0, n would equal, we could add 3 and divide by 2, and we would get 3 halves. So we have to do like we've done on all of our examples. We need to check both of these solutions and make sure that they don't make the denominator equal to 0 in our original problem. So if n equals negative 3, n plus 3, if that was a negative 3, those denominators would turn out to be 0. So this one cannot be our solution. But would 3 over 2 be okay? So 3 over 2 would still be okay here. If we plugged it in here, that would still be a non-zero number. And here would not equal 0 either. You can tell right there, n would have to equal 3 for this one to be 0. N would have to be negative 3. And n would have to be 3 or negative 3 for this one. So as long as it wasn't a 3 or a negative 3, we were okay. So n equals 3 over 2 is our only solution for this one.